A model for data load reduction and energy saving in distributed sensor networks. The volume of data and the energy consumption in sensor networks are some of the most critical problems for the development of IoT applications. Sensor networks can capture a large amount of redundant data. For this reason, some works have been carried out on compressed sensing to reduce the number of sampling points for saving energy and communication resources at data acquisition level. In this paper, is presented a novel model that combines energy savings for data transmission at the sensor node level, and a PCA-based compression method in the gateway node for reduction of Internet data load. The model has a low computational cost and can be calculated in mid-range MCU. The reduction in the data load can represent a significant saving in storage, transmission size, transmission time, and consequently an economic saving. The results are presented for the data load reduction achieved with the data acquired through the deployed sensor network at the ITM, Control Systems, and Robotics Lab. In addition, the validation of the method is performed with the Intel Berkeley Research Lab data. For this work, a wireless network consisting of 5 sensor nodes and 1 gateway node was deployed. Configured in a star topology and operating at 2.4 GHz using IEEE 802.11n. For the sensor nodes, it is taking into account that several measurements are required to calculate PCA at the gateway node. The node startup time and power consumption are reduced considerably since the device should not be connected to the network for each sampling. The simplified form of the model is presented in equation for IM2. The measurement of a variable is stored using the backup SRAM of the low-cost MCU, and the device enter into sleep mode between each sensor reading. The radio functions are turned off until N samples are achieved, at which time the radio is turned on and the data are sent to the gateway node. The flowchart for energy saving at the sensor nodes is shown in the figure. For the gateway node, the measurements of a variable from several sensor nodes are compressed using PCA to reduce the data load to the Internet. The figure shows the flowchart for the gateway node. In the figures are shown the measurements acquired in the nodes of the deployed sensor network, and the corresponding compressed measurements. The table above shows the compression ratio for different values of P, NW, and K. The columns for P show the compression ratio for 3, 6, and 9 sensor nodes. The table below shows energy measurements for different N values. The first and second rows contain the measures for Mode 1 and Mode 2 respectively. The last row shows the ratio between the values of 2 modes. The experimental results for the energy-saving model are shown in the figure for a single sensor node. In the table is shown the variation of the MSE according to the number of nodes, and the number of components used. This paper presents a data transmission model for a WSN with a star topology, which allows reducing energy consumption to 10% of the original consumption. This saving is very useful to extend the duration of a battery-powered node or to reduce the sizing of solar-powered nodes. A PCA-based model was presented that allows compressing the data and reducing the load by up to 19%. This model has a low computational cost and can be calculated in mid-range MCU. The reduction in the load can represent a significant saving in storage, transmission size, transmission time, and consequently an economic saving.